Hello guys, welcome back to Mason African Motives. Still on our revisions for the derivatives, which is working on our differential calculus. I want us to consider this question paper. Let us see how you're supposed to answer these typical questions. That is April 2021 question paper, which is a request that was given. So I'm just going to quickly try and see how we are supposed to attempt these typical questions. As you can see, that is 20 marks everything here. All right, so 3.1, we are given differentiate y is equal to the square root of sec x, and we are given this using the chain rule or function of a function. That is the same method with chain rule or the function of a function. Let us see our question here. All right, so in this case, I'm just gonna rewrite our question. We are given that y is equal to the square root of sec x in this case. We are told the method to apply, which is the chain rule or the function of a function. It's lucky enough that we are given also this formula in our formula sheet, but this is not something that you're supposed to work on, because you are supposed to know, even though you're given your formulas, you're supposed to know which one exactly is it that I'm going to apply for the chain rule. All right, so the formula for the chain rule is going to state that the derivative of y with respect to x is equal to the derivative of y with respect to u times the derivative of u with respect to x. So you're going to wonder to say, how is it I'm working with y and x? Then here I'm now talking about u. I'm now talking about you. What is it that we are now referring to here? All right. We are going to understand this if we consider from this one, function of a function. It means in place of a function that we are seeing, we are going to introduce another function. All right, let us see. We can rewrite, remember the square root simply means to the exponent of a half. So we are going to have this as y is equal to the sec of x in this case. All right, everything being raised to the exponent of a half. So the question is, this is our function. How can we write this in terms of another function? We are going to introduce that function being referred to as u, since we are having here the derivative of u. So that function is going to be taken as u. So we're going to say let u be equal to the function that we have. That's function of a function. So we are going to have u being equal to the function of which sec x, which is the trig function in this case. We're going to have y being equal to the u being equal to the sec of x. The moment we are saying this is now represented by u, it means everything is going to change. This part, we are not going to have it the way that it is written here. We are going to have this part as u, this sec of x, now represented by u. So let us see what we're going to have. So we're going to have this as y is equal to, in place of the sec of x, we are now substituting with the u, which is the function representing the sec. So we're going to have u to the exponent of a half. So that's it. So that's where we are obtaining these derivatives. The derivative of y with respect to u, meaning to say we are working with this part of y and u. The derivative of u with respect to x, meaning to say we are working with the u with respect to x. That is the condition. All right, so let us find our derivatives here. From u, we are going to differentiate with respect to x. So it's going to be the derivative of u with respect to x is equal to, what is the derivative of sec x? So remember, sec x gives us sec x tan x, all right? Just for the benefit of us also knowing and how to apply our formula sheet. So like I said before, the chain rule or the function of function formula you are given. And also you have got the formula for the product rule you are given, and also the quotient rule you are given. These are the only ones that you are having. All right, then these are our derivatives here, whereby we are given the derivative of y in this case with respect to x. So sec x, like I said here, is going to give us sec x tan x. That is our derivative. So meaning to say, this part is going to give us sec x, right? This part we are going to obtain sec of x and tan x. Okay, then we move on to the derivative of y with respect to u. So the derivative of y with respect to u is going to be, remember when you're given an exponent like this, you're going to drop the exponent, then you subtract 1 on the exponent. So we are going to drop the exponent, which is half times a 1 here is going to be a half. Then it's going to be u to the exponent of half minus 1, which is going to give us a negative half. Just for the case of simplification, it's best for us to just apply our exponents, simplify this. A half times u to the exponent of negative half simply means we've got a half times, remove the negative from our exponents. This is going to be 1 over u to the exponent of a half. Then we know that to the exponent of a half means the square root of. So we're going to have 1 over 2 times 1 over the square root of u. Then we can multiply the numerator and the numerator. That's 1 times 1, which is 1. 2 times the square root of u, which is 2 square root of u. So meaning to say, this is what we are going to have at the end. If we are to simplify this part here, we are going to have the derivative of y with respect to u as 1 over 2 the square root of u. So we're going to have 1 over 2 the square root of u like this. All right. So this is what we have, and we are going to conclude now to say, all right, since we have the derivative of u with respect to x, then also of y with respect to u, which is the part of our formula here. Therefore, we are going to substitute the derivative of y with respect to x is going to be given as what? The derivative of y with respect to u, which is the derivative of y with respect to u, we obtained 1 over 2 square root of u times the derivative of u with respect to x, the derivative of u with respect to x, which gave us the sec of x tan of x. You are now substituting into the formula for function of a function or chain rule. You have a formula, so you're simply substituting. What you just needed there was to find the derivatives separately. But if we are to check, this is a derivative of y with respect to x, yet our answer is containing or is having u. We are supposed to remove this and write it in terms of x. So we are now back to say, remember, u is equal to the sec of x. In place of u, we are going to substitute the sec of x, but also we can multiply because this is same as over 1. So 1 is going to multiply the numerator. We are going to have the sec of x tan of x over, we are supposed to have 2 square root of u to the square root of u. But remember, I said the u is represented by sec of x. So we are going to write our answer in terms of x. So therefore, that would be the derivative of y with respect to x. Everything that we have here is in terms of x. Not to say we've got x and we also have u, whilst our derivative is with respect to x. This is the most important part. All right, so that is how we are supposed to answer this question, applying the formula for the function of a function. All right. Then we have a condition on 3.2 to differentiate the following expression. All right, whenever you're given these expressions or this typical question of this nature, what you just need is to rewrite each and every part in the form. Okay, let me show you from your formula sheet so that we understand each other here. these are the derivatives, guys, that we are given. And that is how you are supposed to write your question in the form. We are supposed to rewrite in this way so that we can be able to find the corresponding derivatives. All right, so each and every part must be rewritten in a way that you're supposed to differentiate using your standard derivatives in this case. All right, so let us check if we are together here. That's y is equal to the sine of 2x plus 1 over the cos of x. So if you check, we do not have such on our formula sheet, and even us to differentiate this is difficult. So what are we going to do? We are going to separate this. Remember, I said a plus b over c is the same thing as writing it as a over c plus b over c. As long these are separated together with c, it's the same. So if I am given the sine of 2x plus 1 over the cos of x, I'm going to separate this as the sine of 2x over the cos of x. Take note of this. Plus, I move on to the 1. So it's going to be 1 over the cos of x also. I have separated this part. But still, look what I'm having here. It's a complicated part again, which I have to separate. But if we are to check, we do not have the identity of the double angle here on our formula sheet. We are just given the identities for the compound angles and also for the Pythagorean, which is our square identities in this case. These are the only ones that we are given. We do not have the double angle. So meaning to say you are supposed to know your double angles by heart. You are supposed to know your identities in this case. All right. So what is equivalent of the identity for sine 2x? Remember that the sine of 2a, all right, the sine of 2a is equivalent to 2 sine a cosine of a. So meaning to say sine 2x, we're going to have 2 sine x cos x. So this was going to give us 2 sine x, the cosine of x, over the cosine of x, plus 1 over cos. We cannot just keep on rewriting. We know that 1 over cos is sec of x. So we can write this in a simpler way, which is the sec of what? The sec of x. On this part, we can simplify since we can see that we've got the cos of x and the cos of x here. We can cancel. We remain with the sine of 2x. So meaning to say we are going to have 2 sine x, plus the sec of x. So this whole part that we see here, this whole part that we are seeing here was supposed to be just written as this so that we can be able to differentiate it properly. So now we are going to have, in place of this whole part that was given before, we are going to rewrite it as y is equal to, we obtained 2 sine x. Take note, we are not differentiating, we are just rewriting so that we'll be able to differentiate later on. All right, then we move on to the second one. The second part here, it's fine. We can just maybe separate like 1 over 14, but it's fine. This one, 1 over 14 e to the exponent of 7x, so that you properly see the constant and the term. All right, also this one is fine. There's nothing to change. All right, also here you can just write as 1 over 4, but it's fine as it is, plus 1 over 4 pi to the exponent of 3x and minus 2b. There's nothing wrong here. Half-ln x, also there's nothing wrong. Just gonna rewrite because of this part that we have to rewrite. But if you wanted, you can just, after rewriting, then differentiate this. It's fine. But it's fine for us also to just work it stage by stage. So this is the y that we are given before here. Just we simplified here. Therefore, let us differentiate y with respect to x. So what is going to be the derivative here of y with respect to x? So the derivative of y with respect to x, all right, take note, sine changes to a cos. All right, this is what we have here. Let me just show you also the benefit of our revisions. All right, I'm supposed to go this way here. That is the derivative of a sine, we have everything from our formula sheet. Sine changes to a cos. All right, then we talked about sec changing to sec x tan x. So these derivatives we have. So we are just going to multiply by 2 in this case, this 2 here. So it's going to be 2 cos of x. All right, we move on to sec. Remember sec, we find this as sec of x tan of x. All right, then we move on into e to the exponent of 7x. In actual sense, if we are to differentiate with respect to x, ka to the exponent of f of x like this. All right, this is a function of this nature that we are seeing here. How can we differentiate this? All right, so the derivative of this, I said, is the constant times you are going to rewrite, or you are going to have this function, but what you need is the derivative of f of x first. So we need the derivative of this function. So we're going to have the derivative of f of x times the original function as it is, which is a to the exponent of f of x. Then ln of the base, which is a. Then we're going to multiply this to ln of the base. So take note, the constant is the number, then the derivative of the function, then you rewrite the function as it is, then ln of the base. If we were to consider this, if we are to consider this, actually we have to consider this. We are going to see that on the e part here, this is what was going to happen. This is k, which is 1 over 14. So we're going to have 1 over 14 times the derivative of f of x, which is the derivative of 7x, which is 7, times a to the exponent of f of x, which is e to the exponent of 7x, times the ln of a, which is the ln of the base, which is the ln of e. This is what we're supposed to have. And if we simplify this, 1 over 14 times 7 is going to be 1 over 2. Then the ln of a, e, remember, is 1. Remember that ln e is equal to 1. So we are going to have this as a 1. So it's 1 times this, which is going to be 1 over 2. So the whole part was going to give us 1 over 2 e to the exponent of 7x. So if you want to write the ln e, it's up to you. But as you can see that the ln of e is equal to 1. So that is how we're supposed to have this part here. The same thing with the next question here. It's the same approach. We've got a negative in this case. All right. So in this case, our constant can be referred to as a 1. So this is our constant. So it's just 1 times the derivative of, here there's x. So the derivative of x is 1 times a to the exponent of x, which is 2 to the exponent of x, times the ln a, which is the ln of the base number there, which is 2. So 1 times 1 times 1 times 1 is just going to be a 1. So we need to say we are back to 2 to the exponent of x, ln of what? Ln of 2. So these are some of the things that you do not even see on your calculation. They just write the answer, and you'll be wondering, where are these values coming from? That is how you're supposed to have. This is the formula. Apply your formula properly. All right, let us check on this one. We've got our constant there, which is 1 over 4 times the derivative of f of x, which is the derivative of 3x, that is 3, times a to the exponent of x, that is pi to the exponent of 3x, times the ln of a, which is the ln of pi in this case. Right, so here we're just going to multiply 3 times 1 over 4, which is going to be 3 over 4. Then we've got pi to the exponent of 3x, then the ln of pi. We can't simplify, we cannot simplify the ln of pi directly, just have to leave it like that. All right, then we move on to minus 2b. Remember, this is a derivative with respect to x. So every part that do not have x is a constant. So this is a constant. And we know that the derivative of a constant is equal to 0. So it's going to be minus 0. Then here we've got ln. Remember, the derivative of ln is 1 over x. You're also given on your formula sheet here. Let me just show you. The derivative of k ln x is going to be k over x. So this is exactly what we have here. So we're just going to have k over x, of which our k is a half. So we're going to have it like this. a half over x, which means we've got 1 over 2x. So that is going to be plus 1 over 2x at the end. All right, so as we can see, that is how we're supposed to have this this question. So I just hope we understand. So each and every part is given a mark. Each and every part that you're going to write is going to be given a mark. So meaning you are supposed to know your basic derivatives. Your basic derivatives. You're supposed to know them by heart. This can help you to attempt such typical questions. As you can see, it's a basic approach of our derivatives in this case. Let us check question 3.3, which is from the first principles. That was 5 marks for that. From the first principles, we are asked to differentiate y is equivalent to 5x to the exponent of 5. So this is just our f of x here. So we've got our f of x. All right, so this is question 3.3, which is 5x to the exponent of 5 minus 2x. All right, so remember, this is first principles, guys, and we understand that our formula is supposed to be given as f of x. Right, let us have the derivative of y in this case, which is, let us just write the exactly way they are giving us here in terms of y. So it's just going to be the derivative of y with respect to x, which is going to be given as the limit as h is approaching to 0 into f of x plus h minus f of x in this case. All right, everything over h. So with this part, we are going to see that there is a need for us to determine or to find f of x plus h. There's a need for us. We have to determine this. All right, I'm going to explain this in another way, which is going to give us a nice introduction if we are in mathematics and 5. It's going to be a nice introduction whereby you can simply work out this part, then just substitute your values at the end. So meaning to say, you're going to work them stage by stage. You're going to start by f of x plus h, right? So f of x plus h means in place of x, where there is x, we are going to substitute x plus h wherever there is x. So that is going to be 5 into, where there is x, we substitute x plus h like this, to the exponent of what? To the exponent of 5. Minus 2 in this case into x, and our x is now x plus h. So that is it. So the question was, how are we going to expand this? Remember, we talked about the binomial expansion, whereby you're supposed to expand higher exponents, exponent of 4, 5, and so on. Yes, the exponent of 3, you can try to expand with your brackets concept, but when it is the exponent of 5, we are supposed to apply the binomial expansion or theorem. All right, to explain this, make sure that you watch the video on the introduction so that you'll be able to know how to apply this theorem. All right, so we are going to expand the bracket here of x plus h raised to the exponent of 5, and this 5 is simply there to multiply. So meaning to say here we are going to obtain 5 into, all right, remember how to expand. We are going to have the first term raised to the exponent of x from the concept. If we are given, let us just say x plus a to the exponent of n, it's going to be x to the exponent of n plus n, x to the exponent of n minus 1 times a over 1 factorial plus n times n minus 2, n minus 1 here, all right, by x to the exponent of n minus 2, a to the exponent of 2 over 2 factorial, and so on and so on. But if you do not understand this formula I explained just, it's simply the derivative concept that you're going to apply. You're going to say 5x is being raised to the exponent of 5. This is the first term to the exponent of n. So you're going to have x to the exponent of 5. All right. This is the most important part that you just need, the first term. The rest, apply it this way. You are going to have the next term here. You find the derivative of this. You have to find the derivative of that. That is the concept there. If you do not want to go back to the formula, just do it this way. Find the derivative of this, which is the derivative of x to the exponent of 5. It's 5x to the exponent of 4. All right. Then you are now deriving h, which is our a in this case. So we're going to have h. Here it was h to the exponent of 0. Now h to the exponent. So h is just increasing. It was 1, 2, 3, 4, and so on. So this is h to the exponent of 1 over 1 factorial. The exponent of h is your factorial. So on the 0 factorial, we don't write that 0. We do not have that. Okay. So this is the condition, guys. Okay, let's move on. I want you to understand if you consider this. Again, on x, find the derivative with respect to x. So you're going to multiply 4 times 5, which is 20. It's the derivative there. 4 times, remember, you multiply these. So it's going to be 20x. You subtract 1, which is 3. You just find the derivative there. Then on h, you are increasing the exponent. It was 0. Now it's 1. Now it's at 2. Everything over 2 factorial. We move on, and so on, and so on. Find the derivative of this on x. Find the derivative. So it's 3 times 20, which is 60x to the exponent. We subtract 1, so it's now at 2. H is increasing. It's at 2 now, so it's going to be at 3 over 3 factorial. Plus, again, we find the derivative of this. 2 times 60, which is 120. We subtract 1, which is x. And h is increasing. It's at 3, so now it's going to be at 4 over exponent there, which is 4 factorial. We do the same thing. Find the derivative of this. So the derivative of 120x is 120. So that is going to be plus 120. So x is no longer there, because remember the derivative of 5x, you just take this 5. So there is just 120. Then h is increasing. That's h to the exponent of 5 over 5 factorial. That's it. So we have done. We are done, because here, if you see, the derivative of 120 is going to be a 0. It's a constant. So there's nothing that you're going to have at the end after this. But here we were expanding this part. Remember, this is our, let us write properly. This is our f of x plus h. We applied our binomial expansion to expand this part here, but there's a part that is remaining if we are to consider, or if we are to check properly here, which is this part. So here there's nothing to apply our binomial expansion. We're just gonna expand by -2. -2 times x, which is -2x. -2 times h, which is -2h. So that's it. So here we are going to simplify. And as we are simplifying, I want you to pay attention on this part. Please pay attention here. This is what you're going to do. 5 is going to expand every term inside. Every term is going to be multiplied by each and every term inside the bracket is going to be multiplied by what? By 5. So here we are going to have 5 times x to the exponent of 5, which is 5x to the exponent of 5. Then it's 5 times 5 here. This is 1 factorial. 1 factorial, guys, is just a 1. So it's just 5 times 5, which is going to be 25 x to the exponent of 4h. Then here we multiply 5 times this 20. So 5 is going to multiply this part here. So we can even use our calculator there. All right, let me just show you how we are going to use a calculator. But it's a straightforward factorial. You see it on your calculator, it's given. So you just need to apply the calculator properly. So let me just show you the other part of the screen here. All right, so this is what I'm trying to say, guys. All right, so I hope we can see the calculator now. So this is what we have. We are going to multiply by 5. Remember, I said 5 multiplies here, so it's going to be 5 times. Here we've got a fraction, so we're going to have a fraction of 20 over 2 factorial. So you need 2 factorial, so it's 2 then this is your factorial here on x, this one. So in order to access this, is going to be shift, press this button here, that's 2 factorial, which is going to be 50 in this case. All right, so there we are going to obtain 50. So it's plus 50x to the exponent of 3, h to the exponent of 2. So this is the same situation or the same scenario that you're going to apply even on this part. We are at this part here. So 5 is going to multiply this part also. All right. So let us see our calculator again. 5 is going to multiply that whole part. We are at this point here. So it's going to be 5 times 60 over 3 factorial. So it's a fraction here, 60 over 3 factorial. So that's our factorial there, which is 50 again. So this is going to give us a 50. So we are going to have 50x to the exponent of 2, h to the exponent of 3. We do the same thing. 5 here is going to multiply this part here. All right, so 5 is going to multiply this part this time. So that is going to be, all right, let us just remove this part here. All right, so now it's 120 at this point of 120 here. All right, so it's going to be 120 over 4 factorial. So that is 4 factorial, which is 25 in this case. All right, so we are going to obtain 25. Okay, that is going to be 25 x and h to the exponent of 4. You do the same thing here, guys. 5 here is going to multiply this part at the end. All right, so just for the sake of revision, let us just finish up and see what we were supposed to have. So this last part, it's 120 over 5 factorial. So it's going to be 5 factorial here. All right, so that's a 5 factorial. All right, so we are going to obtain a 5. All right. Okay, is that part what I'm supposed to have in this case? All right, so that is going to be a 5. Okay, sorry for that. Okay, this is a 5. So we are going to have this as 5h to the exponent of 5. So we are done in this case on our application of the bracket. The bracket, this 5 is multiplying up to the end. So this is where our bracket is ending. This part is not affected by 5. So we are going to have it as it is, meaning to say we are going to have minus 2x minus 2h. That is what you're supposed to have at the end for f of x plus h. So the question is, if this be my f of x plus h, like I was saying, this is what you're going to need here on your formula. We are going to need f of x. Take note, I said let us combine this at once. We are going to need f of x plus h minus f of x minus f of x. So simply we can just subtract. This is our f of x here, which is 5x to the exponent of 5 minus 2x. So let us find f of x plus h. So I'm just going to write here f of x. Okay, so this is going to be f of x plus h minus f of x. So we're going to subtract our f of x. Remember, our f of x is going to be minus, our f of x was given as 5x to the exponent of 5 minus 2x. So if we are to subtract, it's going to be negative times 5, which is going to be negative 5x to the exponent of 5, negative times negative here, which is going to be positive 2x. So collecting like terms, this 5x to the exponent of 5 on our f of x plus h, this one is going to cancel with this 5x to the exponent of 5 here. Then we've got 2x and minus 2x. So this minus 2x and 2x will cancel. So meaning to say our f of x plus h minus f of x is going to be the remaining part, which means we are going to remain with 25x to the exponent of 4h plus 50. This one, x to the exponent of 3, h squared plus 50x to the exponent of 2h cubed plus 25x h to the exponent of 4 plus 5h to the exponent of 5 minus 2h. This is what is going to remain because we have subtracted, in this case, f of x. So those two cancel. But as we can see also on our formula, we are going to need over h. We are going to divide by h in this case. We have subtracted this time. So we are going to need this to be divided by h. All right. So this is what we are going to have for f of x plus f of x minus h in this case over f of x minus f of x plus h minus f of x over h. All right, it's good to be writing down. So what are we going to have at the end is that, as we can see, h is common here on the f of x plus h minus f of x. H is common. So we can factor out that h so that we can divide to the h that we need in the denominator. So if we factor out h, this is going to be 25 x to the exponent of 4. All right, h divided by h, that's a 1. Then here we factor out h, so we're going to have 50 x to the exponent of 3. We divide h squared divided by h. This is going to be h. All right, plus 50x to the exponent of 2. We divide h cubed divided by h. So it's going to be h squared plus 25x, we divide h to the exponent of 4, divide by this, h is going to be h to the exponent of 3. Here there are 5 of them, so it's going to be 5h to the exponent of 4. Here it's only 1, so if we divide h and h is going to be -2. So that is what you're going to have. And everything is over what? Is over h, like this. So that means here the h and the h is going to cancel. This is what we are going to remain in place of our f of x plus in place of f of x plus h minus f of x over h. Then we now finalize everything, because after this we are going to need the limit now, because this whole part, we now have this whole part here. So we are going to limit the h to 0 so that we obtain what? Dy dx. All right, so in order for us to have dy dx now, we are just going to apply our limits in this case. So remember that the derivative of y with respect to x is equal to the limit of h is approaching to 0 of f of x plus h minus f of x, everything over h. And we have determined this. This is our f of x plus h minus f of x over h. We have determined this is what we have. So we are simply going to apply the limit. H is going to be approximated to 0. So wherever there is h, we are going to have a 0 there. Wherever there's h, here there's h, we are going to have a 0. Here there's h is going to be a 0. Here there's h, here there's h. So at the end, our derivative of y with respect to x after we limit our h to 0 is we are going to remain with this term, because that part we do not have h. So we are going to have 25x to the exponent of 4. And also this part here, we do not have h. So we are going to remain with -2. All right, so that was how we're supposed to answer this question. If you are to work it separately, stage by stage, taking it from the formula. Yes, we could have substituted each and every part. We write the limit of this each and every stage, which is fine. But because here we are working with so many terms, there are so many terms that are here. So that's why it is very good for us to separate. Find your f of x plus h from your binomial expansion. After that, subtract f of x plus h minus f of x. You find the answer. Then divide by h, which is we are just left now to apply the limits. So this is going to be a nice introduction for you for your mathematics N5, because that is the most important part that we use if we are dealing with more terms. If the terms are many, separate them. All right, let's check the other part of our question here. All right, with the last part, which was question 3.4, that is, we are given the function, the cubic function. Then from this cubic function, we are asked to determine the coordinates of the points of inflection using the second derivative. We are actually told what to use to apply second derivative, of which you are supposed to know this whenever you're dealing with a point of inflection. You are supposed to use the second derivative. The first derivative is for the turning point, for maximum and minimum values. But for the point of inflection, you are going to use what? We are going to use the second derivative. So the second derivative with respect to x must be equal to 0 at the point of inflection. At the point of inflection. This is what you're supposed to have. So whenever you are considering the point of inflection, you use the second derivative. If it is f of x, it means the second derivative with respect to x must be equal to 0. So that means you're supposed to find the first derivative with respect to x. You're supposed to differentiate with respect to x. We're going to differentiate here, which is 3x squared. All right, multiply here, that's going to be negative 24x. We subtract 1. Then the derivative of 16x, which is going to be 16. All right, and negative 12 is a constant. So the derivative there is going to be a 0. So this is the first derivative. We need the second derivative. So we are going to find the second derivative again, 2 by 3, which is going to be 6. So it's going to be 6x minus 24. In this case, 16 is now a constant. So the derivative is a 0. So we have the second derivative. And we are saying the second derivative must be equal to 0. So it's an equation that you are going to formulate from there, because the derivative, the second derivative must be equal to 0. We are going to have this as 6x, which is now an equation. The second derivative, which is 6x minus 24, must be equal to 0. You are now having an equation that you're supposed to solve. So 6x is going to be equal to what? Transpose this, it's a linear equation, so you can divide by 6 both sides. So x is going to give us 6 into 24, which is a 4 in this case. Having the value of x is not enough, because we need a point. It's the point of inflection, and we know that a point is supposed to have x and y at the same time. So where are we going to obtain the value of y? Because we have the value of x. So the value of y, we are going to obtain it from the original equation. Wherever we are seeing this from the original equation, wherever there's x, we are going to substitute a 4. So it's going to be y is going to be equal to, where there's x, that will be 4 to the exponent of 3. Here there's x minus 12 into 4 to the exponent of 2. Here there's x on 16. It's going to be plus 16 times 4 in this case, all right? 16 times 4 like this. Then minus 12, we do not have x here. So this is how we are supposed to find the value of y from the original equation. So if you are to substitute, guys, properly on your calculator, this one I think is direct. We are going to obtain negative 76. So that is our point of inflection in this case. So we are now having the point of inflection, which is for negative 76 for the value of 1. So that was 20 marks. As you can see, it's important, very, very important, guys, to know your derivatives and also to know the methods. Talk of a function, talk about the product rule, talk about the quotient rule. Make sure that you watch the video on the derivatives where I introduced the derivatives and what you're supposed to know in your syllabus, so that it helps you in revising these question papers now. It is an advantage that you know the basics. Where is it starting from? The basics of your derivatives, introduction of it. So we shall talk of more as we are moving on, and make sure that you join the membership family. By joining the membership, you have access to ask any question that you want us to work on, so that we can work on that question particularly. So make sure that we join the membership, guys. It helps also to grow our channel as we move on as a family of Lessons on African motifs in this case.